Hello everybody, Mr. Wyatt here, and I put on my special tie today, a nice green tie here. I hope you like it. Because I care about you guys and you matter, so I'm dressing up my best for you. All right, today we are moving into section 6 of topic 4, understanding and writing inequalities. Last week you were working quite a bit with equations, and in equations remember the discussion about the pan scale and how things have to balance on both sides. Whatever you have on one side, you have to have the same thing on the other side to keep it in balance, just like one of those pan scales you see in science class. Inequalities are very similar in terms of how we work with them, but instead of the two sides being balanced, you're going to see the two sides are not equal to each other. So we have what are called inequalities, situations where the two sides are not equal to each other in value. So an inequality is a mathematical sentence in which the two sides are not equal to each other. So we'll be using some different symbols. Instead of using this equal sign that we use in equations, we'll be using some other symbols. We have the greater than symbol, less than symbol, greater than or equal to symbol, less than or equal to symbol. And then we have this feller right here, and that simply means it's not equal to. Okay, it's like an equal sign with a slash through it. Um, it's not equal to it. So a solution to an inequality is any value that makes the inequality true. All right, so why do we even have inequalities? What is the point of an inequality? Well, let's say, for example, we're going to Valley Fair, and here you have a nice picture of Wild Thing, which is a great, great roller coaster. It's a lot of fun. Um, your height to ride on the roller coasters at Valley Fair has to be at least 48 inches. You must be at least 48 inches tall. Some of you might have gone to Valley Fair maybe a couple of years ago, and you weren't able to ride the roller coasters because you weren't tall enough. And now you're thinking, well, sure, now I'm tall enough. So anyway, you could say your height, let's call our height h. Your height must be greater than or equal to 48 inches, for example. Okay, so if they have that sign that has the little guy holding out the ruler, and you go stand in front of it to see if you are tall enough, you got to be, your head has to go higher than where he's holding that ruler. You could express it like this with an inequality. H is greater than or equal to 48. Now what that means is your height has to be more than or at least equal to 48 inches. Okay? So it's a situation where we don't just want an equal sign, because if you were to say, well, you have to be 48 inches tall to ride this ride, well, then I wouldn't be able to ride the ride because I'm not 48 inches tall. I'm taller than that. 48 inches, just so you know, is 4 feet. Okay? So then only people that are 48 inches tall would be able to ride on that ride. But we have the greater than in this symbol as well. So the height, if your height is greater than or equal to 48 inches, then you can ride the roller coasters at Valley Fair. Another example would be your age to legally pump gas at a gas station. As you can see, this young man right here, he's pumping gas. He is not pumping it legally, though, because you must be at least 16 years old in order to pump gas legally in the state of Minnesota, for example. So I could write an inequality for that and say your age, let's call your age A, must be greater than or equal to 16. Meaning that if you are 16 years old, yes, you can pump gas legally at the gas station. But also, if your age is greater than 16 years, you you can also pump gas legally. Now, there are times where you might see less than. Let's say we're back at Valley Fair. Well, at Valley Fair, they have a section in the park that's for the younger kids. It has smaller rides in it. Um, but if you're over a certain age, you're not allowed to go in there and play on that on those rides anymore. So your age would have to be less than a certain amount in order to be able to enter that part of the park, for example. Okay? So that's why we have inequalities. It's in situations where there are multiple responses that would be acceptable for that problem. All right, so when writing inequalities, this is the main thing we'll be discussing today. How do we write inequalities for different situations? Let's write an inequality for these situations. You're going to get the hang of this after we do a few of these, okay? Michelle is shorter than 60 inches. Well, do we know how tall Michelle is? We really don't know. It doesn't say. All we know is she is shorter than 60 inches. We're talking about her height here, so I'm going to use h for my variable, and I'm going to say her height, h, is less than 60, and that would be a good inequality for this situation. Her height is less than 60. Now, I know it's 60 inches, but when writing the inequality, we don't need to worry about putting the label in there, okay? Now notice this time I just have the less than symbol. I didn't add the equal to bar underneath it because it doesn't say that Michelle can be 60 inches tall. It says she must be shorter than 60 inches. So if she is 60 inches tall, then this wouldn't fit, would it? So her height has to be less than 60 inches according to this statement. Let's look at another one. The average temperature is not 50 degrees. I don't know what the temperature is, but it's not 50 degrees, the average. It might be more than 50 degrees. It could be less than 50 degrees. So I'm going to use T for my variable to represent the unknown temperature. I don't know what the temperature is. T, and I like to use a cursive T. We always use lowercase letters when using these for your variables, for your unknown value. I use a cursive T because if I used a regular T, it might end up looking like a plus sign, right? And that could get confusing. So I'm using a cursive T here for the temperature. The average temperature is not 50 degrees. So the symbol I would use here would be the not equal to symbol, like this. The temperature is not equal to 50 degrees. The average temperature could be more than that, it could be less than that. All we know for sure is it is not equal to 50 degrees. Let's try another one. Ben has scored at least 15 points. So think about this for a second. If he has scored at least 15 points, is it possible that Ben has scored exactly 15 points? And actually, yes, that's exactly right. He might have scored exactly 15 points. But if he has scored at least 15 points, it's possible he might have scored more than that too. It's just at a minimum, at least he has scored 15 points. So let's call the number of points he has scored P. P for points. I'll use P for my variable for the unknown number of points. He might have scored more than 15 points, or he might have scored exactly 15 points. So I have greater than or equal to 15 in this case. The number of points he scored is more than 15 or at least 15. It could equal 15 as well. Now, what I want to point out here is when you see at least, sometimes people see the word least and they're thinking, well, least means smaller, so I should use the less than symbol. But it's actually the reverse of that. It's the greater than symbol. Because if it's at least 15 points, then it can't be less than 15 points. It has to be more than or greater than 15. Or it could be equal to 15 because if it were at least 15, if it were equal to 15, that would qualify then. Okay, I hope that makes sense. Let's check another one out here. And my picture is getting in the way. I'm going to have to move my picture here so I can move my screen here. You must be at most 12 years old to attend. So can I attend? I don't think I can attend because it says you must be at most 12 years old to attend. So if you're older than 12 years old, you can't attend. I can't attend. Okay, I can give you a ride, but I can't stay. All right, so we're talking about your age here, right? So I'm going to call that A for age. And it sounds like you must be less than 12 years old. Can 12-year-olds attend? Yeah, because it says you can be at most 12. So if you're 12, you can still attend. So I'd better include an equal to in that as well. So your age must be less than or equal to 12 years. And again, we don't need to put a label when writing our inequality. Okay? Your age has to be less than 12 years old, or you could be exactly 12 years old and you would qualify. Okay? Hopefully you're getting the hang of this. Let's look at some more here. Steve's height is at least 48 inches. So Steve could be 48 inches tall exactly. Can he be under 48 inches? Nope, he has to be at least 48 inches tall. Could he be more than 48 inches tall? Yeah, he could be. It's kind of like that example at Valley Fair where your height has to be 48 inches or more to be able to ride safely on the roller coasters. So I'll just put H is greater than or equal to 48. His height is at least 48 inches tall. And again, you see at least, which can be confusing, but that means it can't be less than 48. It has to be greater than or equal to 48 inches. At least and at most are two of the key phrases you will need to know when writing your inequalities. At least is going to be greater than or equal to. At most is going to be less than or equal to. You will see those show up quite a bit. All right, the number of marbles in the jar is less than 75. Maybe there are some marbles in the jar and you're supposed to guess how many are in there. All we know is it's less than 75, okay? So could it be exactly 75 marbles? No, because that wouldn't be less than 75. So the number of marbles, let's call that M for marbles. You might have thought, well, I was going to call it N for the number of marbles. That'd be fine too. But I'm going to call it M for the number of marbles. It's less than 75. So I have my less than symbol and I have 75. That's how I would express that as an inequality. The length of the fish must be at least 10 inches to keep it. Otherwise, you have to throw it back in the water. Okay? This is very common, by the way. If you don't go fishing much, you might not realize this, but certain species, like walleye, they won't let you keep it unless it's a certain size. So the length of the fish must be at least 10 inches to keep. Let's call the length of the fish F. Can I call it F? Yep. All right, the length of the fish, if it's at least 10 inches, it must be more than 10 inches. But would a 10-inch fish be one I could keep here? Yeah, so if it's equal to 10, that would be good also. So again, excuse me, this is a situation where I want to include the equal to as well, because if it is 10 inches long, you can keep it. All right, so F is greater than or equal to 10. Students can have no more than 2 referrals. Students can have no more than 2 referrals. Is it okay to have fewer referrals than that? Sure. Is it okay to have more than 2 referrals? No. What if you have exactly 2 referrals? Well, then you still qualify, but if you have more than that, then you don't qualify anymore. So it could equal to or it could be less than 2. All right? So let's call the number of referrals R. R for referrals. You must have fewer than, so that's the less than, or equal to 2 referrals. So the number of referrals that you have must be less than or equal to 2. Are you getting the hang of this? F2 tornadoes. Tornadoes are always rated by the wind speed, and they have a scale called the Fujita scale. It was devised by a person whose last name is Fujita. And so an F2 tornado, F2 tornadoes have sustained winds of 113 miles per hour or greater. And actually, there's a point when the winds get strong enough that it would become an F3 tornado. But for the sake of this example, I'm going to choose a variable for the F2 tornadoes, the wind speed. Let's call that W for the wind speed. I'm going to use W for my variable. The winds must be 113 miles per hour or greater. So equal to or more than. So we have greater than or equal to 113. And that would be a tornado that qualifies as being an F2 tornado. Okay, so that's it for today. I hope this helps. I hope this seems easy. I will see you tomorrow.